Hi, myself A. Navin, rule number 49, and my topic is about address resolution protocols. Address resolution. Finding hardware address for protocol address is called address resolution. Data link layer resolves protocol address to hardware address. Resolution is local to a network. Network component only resolve address for other components on same network. Address resolution. A resolves protocol address for B for protocol message from an application on A sent to an application on B. A does not resolve a protocol address for F. Through the internet layer, A delivers to F by routing through R1 and R2. A resolves R1 hardware address. Network layer on A passes packet containing destination protocol address F for delivery to R1. Association between a protocol address and a hardware address is called a binding. There are three techniques. Table lookup. Bindings stored in memory with protocol address as key. Data link layer looks up protocol address to find hardware address. Closed form computation. Protocol address based on hardware address. Data link layer derives hardware address from protocol address. Dynamic. Network messages used for just-in-time resolution. Data link layer sends message requesting hardware address. Destination responds with its hardware address. Closed form computation. If hardware technology uses small configurable hardware address, network administrator can choose hardware address based on IP address. Example, hardware uses one octet address that can be configured. Simply choose hardware address to be host ID. Now any host can determine hardware address as hardware address is equals to IP address and OXF. Dynamic resolution. Use the network to resolve IP addresses to hardware addresses. Message exchange with other computers returns hardware address to source. Two designs. Server based. Computer sends message to a server to resolve the address. Every computer would need list of server or broadcast to locate servers. Distributed, all computers participate. Destination provides hardware address to host. Address resolution protocol ARP. IP uses dynamic distributed resolution technique. Address resolution protocol ARP part of TCP IP protocol suite. RFC 826 address resolution protocol two-part protocol. Request from source asking for hardware address, reply from destination carrying hardware. ARP message exchange. ARP request message dropped into a hardware frame and broadcast. Sender inserts IP address into message and broadcast. Every other computer examines requests. ARP message exchange. Computer whose IP address is in the request response puts its own hardware address in the response. Unicasts the response to the sender. Original requester can then extract hardware address and send IP packet to destination using a recently acquired hardware address. ARP message contents. Hardware address type is equals to 1 for Ethernet. Protocol address type is equals to 0 into 0800 for IP. Operation is equals to 1 for request, 2 for response. Contains both target and sender mappings from protocol address to hardware address. Request set hardware address of target to 0. Sending an ARP message. Sender constructs ARP message. ARP message carried as data in hardware frame encapsulation. In ARP message, frame header, frame data area and CRC will be present. Processing the ARP messages. Receiver extracts sender's hardware address and updates local ARP table. Receiver checks operations, requests or response. Response adds sender's address to local cache, sends pending IP packets. Request. If receiver is target, forms response. Unicast to sender. Adds sender's address to local cache. Note. Target likely to respond soon. Computers have finite storage for ARP cache. Only target adds sender to cache. Others only update if already in cache. ARP bridging and routing. ARP is transferred to bridging since bridging will propagate ARP broadcasts like any other Ethernet broadcast and will transparently bridge the replies. A router does not propagate Ethernet broadcasts because the router is a network level device and Ethernet is a data link level protocol. Therefore, an internet host must use its routing protocols to select an appropriate router that can be reached via Ethernet ARPs. After ARPing for the IP address of the router, the packet targeted at some other destination address is transmitted to the Ethernet address of the router. Proxy ARP. Proxy ARP is a technique that can be used by routers to handle traffic between hosts that don't expect to use a router as described above. Probably the most common case of its use would be the gradual subnetting of a larger network. Those hosts not yet converted to the new system would expect to transmit directly to hosts now placed behind a router. A router using proxy ARP recognizes ARP requests for hosts on the other side of the router that cannot reply for themselves. The router answers for those addresses with an ARP reply, matching the remote IP address with the router's Ethernet address, in essence a LI. Proxy ARP use. When host A wants to send an IP datagram to host B, it first has to determine the physical network address of host B through the use of the ARP protocol. As host A cannot differentiate between the physical networks, his IP routing algorithm thinks that host B is on the local physical network and sends out a broadcast ARP request. Host B does not receive these broadcasts, but router R does. Router R understands subnets, that is, it runs the subnet version of the IP routing algorithm and it will be able to see that the destination of the ARP request from the target protocol address field is on another physical network. If router R's routing table specify that the next HOP to that other network is through a different physical device, it will reply to the ARP as if it is were host B, saying that the network address of host B is that of the router R itself. Host A receives this ARP reply, puts it is in his cache and will send further IP packets for host B to the router R. The router will forward such packets to the correct subnet. The result is transparent Subnetting. Normal hosts such as A and B don't know about subnetting, so they use the old IP routing algorithm. The routers between subnets have to use the subnet IP algorithm, use a modified ARP module which can reply on behalf of other hosts. Inverse ARP used on point-to-point links. Find IP address of the host on the other end. Used in frame relay and ATM. Uses codes 8 request and 9 response. Node to switch. That's all about my topic. Thank you.